So solving literal equations is really it's just solving equations as per normal, but instead of getting an answer of x equaling 3 or 6 or 2, it's x is equal to k or x is equal to c. I think the change that we had in the exam for last year in 2017, I think it's a good idea to get practice at solving our equations in terms of a third variable, okay? So processes are the same as if you would solve per normal. So here we have a quadratic equation, so let's come out here. And to solve a quadratic, typically we might use the quadratic formula. So a is equal to k, b is equal to 2, c is equal to k, okay? So x is equal to minus b plus or minus the square root of b squared minus 4 times a times c over 2a, which is k. So that's equal to minus 2 plus or minus the square root of, what's that, 4 minus 4k squared over 2k. So there's not a lot we can do there. We might be able to take 4 out as a factor. Negative 2 plus or minus, we'll take the square root of 4 out of the square root of, and that makes me a 1 minus k squared over 2k, which means I might get a negative 2 plus or minus 2 square root 1 minus k squared over 2k. 2's will cancel, so we get negative 1 plus or minus the square root of 1 minus k squared. So that's what x is equal to, all right? I guess we could have tried to factorize, complete the square, all those things, but I think the quadratic formula was probably the easiest one. Let's have a look at B. Let's rub out that line there, I think. This makes it a little bit messy. So B, we've got a quadratic, common factor of x there. So if I take x out the front, I've got x squared minus 3ax plus 2a is equal to 0. So if we just look at that, obviously x is equal to 0, so we've got to look at factorising that expression here. So if we had 2a and 3a, no, we're not going to be able to by inspection, so we're going to have to go quadratic formula again probably. So a is 1, b is negative 3a, c is 2a. So let's go with minus b, get positive 3a, x is equal to plus or minus the square root of b squared minus 4 times a times c over 2a. That means that x will equal 3a plus or minus the square root of, what's that, 9a squared minus 8a over 2. Now we're not going to be able to do a real lot here. Now, sort of the a squared and the a, you could take 8 as a factor, but it's going to give a square root sign. 9 and 8, nothing there we can really simplify with. So that might be our final solution. X is just equal to that. Okay. Final one here. Let's come to C. So solving for x means getting x on its own. So let's divide by b both sides. Equals c over b. Take a cube root. X minus a is equal to, so the cube root of c on b, which is the same as c on b to the 1/3. So x is equal to a plus the cube root of c on b. All right, so there's what x is equal to. So the steps that we took in all three of those were exactly the same as if those k's were numbers, but we've got a general solution if you like. last one here. Give yourself a bit more room. So what have we got? Solve f of x equal to 0. All right, so I need to solve. Let's come over here a bit. X cubed plus k plus 1 x squared plus k x equal to 0. So we take x out as a common factor. I've got x squared plus k plus 1 x plus k equal to 0. So x is equal to 0 is one solution. So now, again, quadratic formula. X is also equal to minus b plus or minus the square root of b squared 4 times a times c over 2a. Let's come over here. So x is equal to, I'll make it minus k minus 1 plus or minus the square root of k plus 1 all squared is k squared plus 2k plus 1 minus 4k over 2. So x is equal to, I might leave it factored, sorry about chopping and changing, square root of k squared, 2k minus 4k is minus 2k plus 1 now, over 2. So we're now going to have x equals negative k plus 1 plus or minus the square root of, that's equal k minus 1 all squared over 2. So I get x equals negative k plus 1 plus or minus. Now, square root of k minus 1 all squared, they cancel. So I get k minus 1 over 2. So if we like, x is equal to, well, let's expand it, negative k plus 1 plus k minus 1 over 2, or negative k, that's a minus in there, minus 1 minus k plus 1 over 2. So what does that give me? Minus k minus 1 plus k, negative 1 minus 1 is negative 2, negative 2 on 2, minus k is minus 2k, negative 1 plus 1 is 0 over 2, so x equals negative 1 and k, negative k. Yeah, so there's my two solutions, and don't forget our x equal to 0 from earlier. Okay, so that's really the end of the chapter work. So work through those. Quiz coming up.